Alright guys, we've got another video here. Just kind of want to walk you through the next section. And now we're looking at Pythagorean theorem. So we have our right triangle here, as we usually do. And then we have a question here just saying, what is the length of x, what is the length of xy? And when it says that, so that means line segment xy. So it means from x down to y. So it's saying, what is this length right here, this side of the triangle? And so when you see this, or if you see a problem like this, we need to be able to recognize a few things. One, we need to be able to recognize what are the short sides and what is the longest side of the right triangle. And so there's a few ways we can do that. We can see down here that this corner right here is our right triangle, or is our right angle. It just looks like a floor and a wall, right? So that's always going to be our right angle. These don't look like that. Notice how these look. They're really small compared to that, right? So we know these are not right angles. So if we know this is our right angle, we also know that the side across from that right angle is our longest side, okay? And that's side C, all right? And then we'd know about the other ones, all right? So when we think about Pythagorean theorem, we know it is a squared plus b squared equals c squared, okay? So in this scenario here, and you've already done one where you just added these two together and you got your answer and you took the square root, but this one's a little different because they give us c, okay? And they also give us, I don't know, either A or B, whichever one. Let's say this is B and this is A, okay? So that's A. And so they give us that information and they give us side B, let's say that. So we don't know A, so we're going to keep it as A squared plus, and then this is 4, so it's going to be 4 squared equals, and we know C, it's 6. So it's 6 squared, or 6 to the second power, 4 to the second power, okay? So now what we have to do is, instead of adding these together, right, there's nothing, we can't add A squared and 4 squared, we don't know what that is. But what we can do is, we can modify it, right? We can simplify. And we can take away 4 squared from both sides, okay? 4 squared minus 4 squared is nothing. It just cancels out, right? So then we would just have a squared. We'd have a squared equals, this is gone. We still have our 6 squared, and we still have our minus 4 squared. This is this right here, okay? That's where that came from. And so now we can just solve this equation, okay? So we have a squared still equals 6 squared. 6 squared is 6 times 6, which is 36, minus 4 squared. 4 times 4 is just 16, okay? And so now we know that 36 minus 16 is just 20, and that's still a squared. So a squared equals 20. And then what we need to do here, I'm going to rewrite it so you guys can kind of see what's happening. We go from here, we rewrite it, and then we need to take the square root. I'm going to make it in red so you guys can see it. We're going to take the square root of a squared. The reason we do it is because we want a. We just want this side. That's all we want. We do not want a squared, right? We need a. And the only way to get the value of a is to take the square root of a squared. If we do that on the left side of the equation, though, we have to do it on the right also. All right? So the square root of a squared is just a. Bring that down. So a, so that just becomes this, right? And then we have a, and then the square root of 20 is just the square root of 20. And the reason we leave it as square root of 20 is because we don't know what the square root of 20 is, okay? We don't know what the square root of 20 is. And here we see our answer is C, right here, square root of 20, okay? All right, so I want to see this on your paper, guys. All right, thanks.